ready? You ready? You ready? You ready? I'm ready. Okay, so some people over or underestimate their height. And what's going on here? This is a self-reported versus a measured heights in males. Okay, as part of some study, bam, human services, self-reported heights. Okay, we pretty much get the gist. What do we want to get out of here? All measurements are in inches. Listed below, we want a 99% confidence interval of the estimate of the difference of means, and interpret the results of the confidence interval, mainly its implications on whether the confidence interval includes zero. What does that even mean? Let's go get the confidence interval and then we'll talk about its consequence. What's next? Oh, I'll put a little formula down here. Boom. Because that's gonna get us our confidence interval. What do we need? We need d bar. We need the standard deviation of the distribution. This is pairs. We're doing the difference of paired data. And they also give you that your error is that guy so that we can go get that. Let's go get D. D is the difference between the pairs, what their reported height was and what their measured height was. So they were like, you're about how tall, and then they actually measured them, and those were their differences. Notice the signs. Some overestimated, some underestimated. Now if we get the averages of those differences, that's D bar. So we're going to go and we're going to do that now. And then we threw them in a calculator and we found that the average was -1. Really? Yeah, so on average they reported their height shorter than their actual measured height. You wouldn't think that that's the way it was, but that's how we got it. Wait, reported minus that. Just kidding. Their measured height was bigger than their reported height. And I wasn't kidding. So in our calculator we also get the standard deviation of that data set D, the difference in heights. We just read it off our calculator, threw them in, bam, hit a button. So we need to go get our T-stat, because we need that down here, bam. And in order to do that, it's the number of pairs minus 1, because that's our degrees of freedom. So 12 minus 1 was 11, and our T alpha over 2 from our chart was 3.106. We looked it right up on the chart with our area, or our alpha over 2 being 0.1 divided by 2, so we looked up our alpha to be 0.05. And that's what we looked up in our chart to get our T value. So now we're plugging them all into this formula. Boom. Keep going. I just put everything where it was supposed to be. And then Wilmer threw him into a calculator, so it's on him. So that's minus 1.91 to minus 0.089. So what does that mean? They ask if that confidence interval contains 0. Does that confidence interval contain 0?
No.
No, which means that you can use a confidence interval to test the claim that they measure different. What do I mean? I mean, if you were testing the claim, our null, HO, would have been that the height measured, that's not an M, height measured was equal to height actual, and our alternative, H1, would have been that they are not, since we were doing a two-tailed test. So if we found our test stat, T, that was, what was D bar? -1 solid.
Yeah.
And then minus mu D, I think that's 0, because we're assuming no difference. What was the standard deviation? I know we gotta go and I'm rushing.
3.52.
3.52.
52.
5, 2. All right, divided by the square root of what was our sample size?
12.
12. Wilmer, can you pound that out while I'm setting up our rejection regions? Bam. Our test stat was 3.1. 106. And then that's negative. And then over here, 3106. Now we're actually testing this thing. This is reject, this is reject, this is fail to reject. And what did our t-value turn out to be?
Negative 0.984.
0.984. Are you sure you put that in there right?
Yes, sir.
Oh. Well, this says we fail to reject. And our confidence interval says that we reject. Something went awry.
Yeah.